In these examples, we want to solve a couple of rational equations. Let's bring up some basic steps to solve these kinds of exercises. Here we go. There's really only two steps involved. The first thing you do is find the least common denominator, otherwise known as the LCD, and then you multiply both sides by that to clear fractions. So by the time you're done, you shouldn't be working with anything in any of the denominators. So let's take a look at part A here. We have 6 plus 5 over y equals y minus 2 over y. Okay, first thing we do is find the LCD, least common denominator here. So let's see, I'm looking at this. I mean, you could write all these over 1 if you wanted to, and we look at all these denominators here. Well, all I'm seeing is y, so our LCD here is y. Okay, now we multiply. I'm getting rid of those over 1s there. We'll multiply both sides of this equation by the LCD, which is y. We're going to clear fractions here. When we do that, what happens? Let's see, so we distribute this y through, so we have 6y plus 5. It's only plus 5 because in the second term here, the y's cancel out. All right. Distribute y on this other side equals, okay, y squared minus, and in the second one the y's cancel out again, leaving us with y squared minus 2. Okay, now it's just a quadratic equation. I say quadratic, what I mean by that is there's a y squared in here somewhere, and a y and a constant. So anytime you see a y squared on one side, you want to get 0 on the other side of the equal sign here. So I'm gonna do a 0 on the left and bring everything else to the right. So y squared, I'm going to subtract off the 6y, so minus 6y. Subtracting off the 5 gives us minus 7. Alright, now we're getting there. Let's factor that. This we can factor, right? We need factors of negative 7 that add to negative 6. So two numbers that multiply to negative 7 but add to negative 6. I'm thinking negative 7 and plus 1 do the trick there. And now we set each one of these equals 0, giving us y equals 7, y equals negative 1. The thing is, with rational equations, you have to check to make sure neither of the answers give you 0 in the denominator. Okay, well this is pretty straightforward on this example here because we only have these two denominators. We check with 7 and negative 1. Neither of these give us 0 in the denominator, thus these are our two answers for that one, y equals 7 and y equals negative 1. Let's try B here. For B we have 2a divided by a plus 2 minus 5 equals 7a over a plus 2. All right, back to our steps again. Our first step is to find the LCD, the least common denominator. Okay, well, I'm seeing the first denominator has a plus 2 in it. I go on to the second one. Anything I need to add? No, that's just 1. Go on to the third one. Anything I need to add there? No, we already have a plus 2. So it looks like our LCD is simply a plus 2 in this case. All right, step 2, we multiply both sides by our LCD so that we can clear fractions. So here we go, a plus 2 on the right and a plus 2 on the left. As long as we do it to both sides of the equal sign, we're not fundamentally changing the equation. All right, this gets distributed through like so. Here we go. So that gives us in the first term it cancels out, so we're left with simply 2a minus, now we have 5 times the quantity a plus 2. Make sure you keep those parentheses in there for something like this. Equals on the right side, well the a plus 2 simply cancel out. 7a, and now we have a nice linear equation. We just need to solve that for a. So let's do it. Let's distribute this negative 5 through here. So we get 2a minus 5a minus 10 equals 7a. I'll get all my a's on the left in this case. So we have 2a minus 5 is minus 3a, and then I'm going to subtract off the 7 as well, so minus 7a equals, I'm going to add the 10 to both sides to get 10 on the right. This is looking pretty good here. Negative 10a equals 10. which gives us, dividing both of those by 10, a equals -1. Now it's tempting to just box this answer and call it a day. Not just yet. We have to check to make sure this doesn't give us a 0 in the denominator anywhere, but we just run it through these two. We plug in the a right here. Notice that neither one of these denominators becomes 0 when we plug in -1 for a. That's good news, so this answer is okay, and that's our answer. A equals -1.